right, I'm getting started on something a little different today. This is just a project that I picked up yesterday, and I'm going to do it today and maybe tomorrow and then get back on track. But I was just feeling real inspired yesterday, and I didn't have a full day worth of time. I only had a few hours. So I whipped up a little pixel art rasterizer and plugged in this tile set that I found out was free open source material. So there's this classic roguelike called Dungeon Crawl Stone Soup, which I'm an old fan of. I know it well enough to be familiar with its tile set pretty well, and then I found out that the entire tile set has been available free and open to use. With a courtesy obligation or a request for a courtesy credits, which seems perfectly reasonable if you do put it into something you distribute. But that makes it a great starting point for a set of icons that I can use to make an interface to some of the RPG simulator stuff I've been building, which, for a lot of it, a purely text interface has been exactly what I needed. It lets me write little mini scripts to put data in and to read back out the data. It's quick and easy to iterate that way. But now that I know this is here, it just got me thinking about how I would go about making a graphical interface with it, and also just how I would, the one thing that this tile set doesn't come with is a whole lot of metadata that is already equipped. So I just got a bunch of files and folders with names basically, and I don't know what's in there totally. I don't have a full comprehensive inventory in my head or in a data file or anything. So getting a handle on that and being able to see what, if anything, I could do with the tiles I think it's going to require me to spend some time building this visualizer or viewer program that I've got. So I'm just kind of playing with it so I can take a look at what's in there, and you can see these look like they are for equipping characters with a weapon. This is the space where a hand goes from a human character who's carrying one of these things. So there's so many ways these can be combined to make characters who are carrying things and icons for things and stuff that it could just be useful as a starting point. And I've got the basically what I did yesterday was loading the files in, and also I set up the pixel art anti-aliasing so I can move and scale these tiles without too much aliasing. I don't know how clear that is on through all the video compression to Twitch, but the pixel art here is not it's not showing to me. It doesn't look like it's distorting and wiggling and sparkling when it moves around. It's anti-aliased properly, but there are some limitations. I can't rotate or stretch, or I can stretch it. That's what I'm doing. I'm scaling it. I can stretch it along the two axes, but I can't rotate it or skew it or flip it because of the way it's built right now. And just thinking about what I might do with these icons, I think one way to use them that would be pretty good for making a good interface might be to actually place them in three-dimensional space, Paper Mario style. Because 2D layout it will be nice for things that are like tiles, like in the game, in the RPG simulator, I talk about things having tiles on them, and how we're going to make an interface to a human. Those tiles would probably appear on a classic UI, grid interface in 2 dimensions. But to put to put a scene together of who is involved and what is the basic health and key status effects on each character right now, to put that information on the screen, I think it would fit better in sort of a 3-dimensional space than in trying to lay it out in 2D well. So I kind of want to fix that. Another problem is, because of the way this is working, the pixel interiors look fine, but the edges are all aliasy still. They move around and they flicker, does the ticking thing. So it looks jittery on the edge. And I don't know if that's coming through on Twitch, but it does look jittery. And the solutions for that are either to make that into an interior by expanding the size of the geometry and putting transparency around each tile, or to use multi-sample anti-aliasing. And if it was going to be placed into 3D Paper Mario style, I think we would want that second one anyways, for the edges. I guess the one thing I haven't thought through is if the presence of transparency would complicate the anti-aliasing, but I don't know if it would. You can still do, as long as there's not like partial transparency. Partial transparency will come out weird, but the fact that these mostly are opaque with transparent, fully transparent, like backgrounds, makes me think that it should be fine to just throw in multi-sampling as the solution for those choppy edges. So, that's what I want to do today. I want to turn on multi-sampling, see if I like how that looks on the edges, and then turn on, or get this thing to a point where I can at least place it rotated, skewed, and flipped in 2 dimensions, because if I can do that much, then the step to 3D is just a matter of adding in depth and a camera, like perspective projection, basically, right? Then the other direction for this project is the metadata half, so I can view these things nicely, but I should be able to create a list of all the assets that are here by file name and start tagging them things like, oh, these are water. Those should all be tagged with a group tag that says they're water tiles, right? And these are clouds. These might actually violate the rule of total transparency. Also, there are some weird artifacts, like sometimes it looks like there's a very thin black outline around the edge of my shapes, and I think it might be an sRGB thing, like it might be a partial transparency and next to a total transparency that blends darker than it should or something. So there's like something weird happening on the edges, not of the shape, the geometry, but on the edge between transparent and not transparent, that might be like either I'm combining. Do you see that right there? Do you see what I mean? Like, how is it I didn't set up anything that renders outlines intentionally, so something weird is happening when I see that. I don't know what that is. So there's a bug to find about this. And then another issue still is, oh, and here are all the tiles. Like if I need an interface filled, you see how there are all those like tiles for magical spells or something? Like these things. These are gonna be super helpful in throwing together an interface quickly. Yeah, that second piece though is I need to be able to like type in a name. Like I should be able to type an L for magic and just get lists of things that match the search term and then flip through them. Right now it's just cycling like 6 times a second. It's flipping to the next tile in the whole set just so I can look at them all. But all these piles of gold are gonna be great. But I think this is not going to be useful until I can actually see the data structured better and search through it for what things that I'm looking for as needed. So with those things in mind, I guess we'll start tracking down some possibilities. I want gosh, there's so going to be so neat to have available once the data is indexed. I want to get to that second part of indexing it because that's like a super useful thing. And once the ability to start generating the metadata is possible, I don't know if that'll be through a custom interface in the viewer, or if I'm just gonna make a text file. Like maybe I'll just throw up a Metadesk parser that I can use to associate each file name to to some properties. But I'm gonna try to take just today and tomorrow to play around with the possibility of using these as interface building. And since I already made progress on the rendering piece before, I want to focus on that a little more. Now, before I get into the project, one last thing I'd like to remind everybody. So that's what we're doing today. If you like any of the projects I'm working on, I've got the base layer that I'm trying to get to. I've got the RPG simulator with all the like C scripting and the alternative state machine scripting kinds of experiments that I'm iterating on, and now this tile set thing, which is also a piece of this. If you'd like to see me keep working on any of it, a couple ways you can help do that. One is you can go to mystifort.com/membership and become a supporter or a member. You can also subscribe on Twitch, and if you can't support but you'd like to follow, there's also a newsletter button right here so you can get updates. But yeah, do check these out if you think you might be able to afford that support or subscribe or membership, and if you'd like to get any of those perks or help to keep me on the path that I'm currently walking on to make these things. So with that all said, today I'm going to focus on the rendering. I've got my shaders. They are using, I now bake my shaders into my program directly with a separate tool from the compiler. That tool is a little bit unprepared for the prime time, but I'm exercising it again with this project. That's my OBJ from raw utility, and I will say it was pretty easy to get these dumped into my program. So this is how I program the shader now, is I just use separate files and link them in. The only thing is that I'm not quite sure that it's all 100% right? There might be a bug in here. I might be about sRGB, so let's go track down some of these issues. First of all, I want to pick a tile. Instead of rotating through them, I want to pick one. So I have some options here. I'm going to turn off the rolling select and turn on the auto select. And then I'm going to select one that has the right I'm going to select one that has the right properties to test what I'm looking for here. I mean, let me see if the one I've got already does. I think Minotaur M maybe did have this. Okay, so this one's actually perfect because on the left, right, and top, these are all interior edges to the texture, right? The geometry goes a little bit around them because the sprite just has, they're all 32 by 32 tiles, but some of them don't use the full 32 height or width, and this is one of those. But it is on the bottom side of the texture, using the bottom row for an opaque couple of outline pixels. And I don't know if you guys can see it, but they flicker, right? The other edges don't flicker when the thing is moving around, but these edges are flickering like this. So to make that stop, that's what the multi-sampling is for. If I turn on multi-sampling and it's working, what I expect I'll see is that all of the edges will look equally good. I could probably accentuate it just to be sure if I change what kind of movement I was using and didn't use scaling at the same time. So let me modify the animation for now. Let's turn off the scaling up and down and just keep it big. And let's modify the wiggle to use just a sort of like that, and we'll go at full, like, equal speeds on both. And so now we should get, whoa, okay, hold on, that's not right. These are no longer half dims, these are scales. And so 120 divided by 32, what is that? Okay. There we go. So hopefully that, I don't know if that helped at all, but at least I can vary. He's constantly moving up and down. Clearly left to right edges are fine, but the bottom edge is funky. Okay, good. Now, let's see what happens when well, yeah, it's just the bottom edges that are on the bottom of the geometry, right? The difference is that the bottom of the hands are interior to the geometry, so they are anti-aliasing through my fragment shader successfully. But the bottom edge is flickering because there's nothing in the texture for it to blend with underneath. And so my two choices are to extend all textures to have a transparency around the edge and extend the geometry around each tile so that everything that is opaque is interior, or just turn on multi-sampling and see if that'll work. And I think I'll need to do multi-sampling anyways if I'm thinking of going 3D with it. So that's why I'm using that as the test case for the geometry edge anti-aliasing problem. Okay, so somewhere I set up a frame buffer. Let's put that music back on there. Yeah, man, rendering is one of my hardest things too. Like, there's just these tiny little things that I feel like I get. Like, it's kind of embarrassing to admit, but it took me like 4 hours just to get this and this figured out. Like, my last iteration of these were so much more complicated, but now that I can write them in separate files, that has helped a little bit. And I didn't try to figure it out this time. I just went and read D7 Samurai's shader toy to figure it out, and so much easier. I mean, I expanded it from his was much more tight, and I didn't understand. I had to work with it a bit to figure out what the intermediates meant and what spaces they were in. So I gave it my classic overly verbose, high overnamed, variable spammy style, but it's working correctly, which I haven't been able to do before. I've always had the like if I ever did like large blocky pixels, I couldn't slide them around or scale them because they'd flicker, and now I finally almost got it. And that's like my big new achievement. And here I'm saying I'm gonna make it 3D like it's no big deal, and it's probably the most intimidating idea I've put myself up to in a long time. Yeah, the graphics APIs are a serious part of the problem. I've thought about just going and trying out Sokal as a project someday too. Like, I should know if Sokal is actually better. A lot of people say it's better for portability, but what I really want to know is does it undo the nonsense? Like, is it less horrible? Do they have great API design or not? That's what I'm curious about. Okay, so this sets up a frame buffer, but we're now going to need a pair of frame buffers. So we're going to have a multi-sample frame buffer and, well, I guess that's it. That's all we need for now. Main, yeah, we don't need to rename it. My mistake. We're just going to make this main buffer a texture 2D multi-sample. And I have other places where I've done this before. I did this back in the day with my rendering code path stuff. So yeah, here's some example code still with multi-canvas texture. And yes, you do use a different text image 2D function in OpenGL. Multi-sample number goes stick that in the settings up here. Let's make it 8. That seems like a good starting point. Honestly, the command buffer queue stuff is the least interesting part. The real graphics programming problems come down to like 3 layers to me that are actually difficult. There's the first layer, which is, hey, how the heck do I write a shader and get it into this thing and bind it, get my errors back, and in such a way that I can actually understand what they're telling me, and then bind my code to the shader. How do I bind to that? That whole process of writing shader code, getting it in, making sure it's right, and then linking to it properly is one thing. The second thing is figuring out how to actually conceptualize your anti-aliasing algorithm. I get so lost in the sauce. My last attempt at doing this thing with the pixel art anti-aliasing, I write like 20 lines of code trying to figure out some way to interpolate between the points, and my people who are good at it boil it down to a very simple map, right? You look at someone, it's similar with like the rounded rectangles, right? When I think about it, it's this fairly complex geometrical problem that spans out like this. But people who are good at it get it down to like, oh, it's a 2D vector, min this 2D vector, max that one, and then this one is, you know, clamped to 0, this one from above, and this one's clamped to 0 from below, and then you add, like, it all just kind of collapses down into like 2 or 3 steps of arithmetic with so many nested little functions that I'm like, I don't know how people who write these do this. I don't get it. I have to spell it out, and it takes forever to grok those super tight expressions. It takes me hours to unpack someone else's really good tight shader code. And I don't know if it's because shaders need to be expressed that way to be efficient, or if it's just shader programs tend to be small programs, and so the people who like to code golf do them better than people who don't. Like, I don't know. It's also just crazy to me that we program shaders in text. And I know that's not what happens in like highly polished game engines that get off of that, because it's nonsense. Okay, now back to, oops, I just need animation starter. So we don't do this. Main frame buffer, bind frame buffer texture, color attachment 0, canvas texture. Oh, and I was going to say there are 3 things. So figuring out the rules of like anti-aliasing, rasterizing, all of that. Finally, the third one is actually building high quality effects, which is beyond me. Like I sit and struggle and work on this, and I never get past that. Once you get past that, then you can actually have some artistic expression. And even if this was something I was capable of, I've never broken through the barriers of the first 2 so well that I could like really sink my teeth into the third one. So I always end up with rather simplistic graphical expressions in my graphics programs. Okay. That might have just done it. I'm not sure. No, that didn't do it. Okay. There's something I'm missing here. Multi-sample canvas. Multi-sample canvas. Okay. We're not doing sRGB stuff, so there's just the one texture. And there's just the one frame buffer. We render to the main frame buffer all day long like this. And then we bind. I'm hesitant to change this just because it's not working, because it was working right up until the change. Oh, you see the issue? It's this. This is a multi-sample texture. Okay, I don't know if you can tell, but that does seem to have fixed the problem. That's cool. I can never be sure what's going to come through video compression and what's not. So here's the whole 9 yards. It's wiggling, or it's not. It's moving all over the place and getting bigger and smaller all at once. Cool. Okay. So I think the next step is going to be to get back into the shaders. And like I said, I kind of want to open it up. So the parameterization right now is a pattern comes in that is 6 points that make 2 triangles that basically define the extreme corners of biunidal square. So -1, -1 down to 1, 1. I get the 2 triangles that make that square, and then I transform them according to a rectangle which I am passed. And I'm also passed the dimensions of the texture. So another thing I don't have in this current system is I can't render multiple tiles from the tile set next to each other. To do that, I would need to do either an atlas and pack them all together, or I would need to do texture array. If they were all 32 by 32, the texture array would be pretty attractive as an option, because then you could just specify which one to render with an index, but some of them are like 48 pixels tall, some of them are like 20 by 20. So you still end up needing to pass dimensions, and then you have a lot more wasted space. And Alice is probably the better option. But the question is if I want to get bogged down in building a texture atlas today, or if I just want to focus on, I think I just want to focus on the transform for now. I'll figure out the UV part a little bit more later. So I'll just keep assuming that I'm getting a texture and all I need is the UV dimensions in the shader. So, and then it'll be 0, 0 to the UV dim.x, UV dim.y is the quad that I'm trying to map. This is going to get replaced with a vector for the direction of the x-axis and a vector for the direction of the y-axis that are scaled according to the sides. So I can basically pass two legs of a trapezoid, right? That's the 2D equivalent of being able to place it freely anywhere. And then I'll have to do a linear solve to map fragment coordinates back to, I guess it's going to be important to kind of describe a little bit about how this anti-aliasing system works. I'm reading some notes that I have on my whiteboard on the side to remind me of what I have to show you. That goes there. Okay. I think that's a good combination of colors. Okay, so imagine that we're going to put down, I'm going to show this to you the way it works now, and you'll see how it is somewhat limited. We're basically saying somewhere there's going to be a, hello? What's the, okay, so basically we have an origin point somewhere. Now what we actually do is whenever we go to place an object, we take a pixel point and we subtract the top left corner of the object we're trying to place. So the origin is always the top left corner of our object by the time we're here, right? Top left corner of the object. You might also call it the sprite or whatever. Now, what the algorithm does is it says, okay, we've got some amount of, our quad fills up some amount of space. So here's our bottom right corner, and it looks like this, right? And then somewhere in there are pixels. And so we might be sampling, when we get to the fragment shader, we might be sampling this point here, right? And I'll just do a little... Okay, so this is our point, and this is in the coordinate space of pixels, or in terms of OpenGL, it's like pixel centers. So this is a pixel center, which means it's some integer plus a half on the x and y coordinates. And even when we subtract the top left corner of our object, it's just some, if that's not, if that's not an integer point, that's fine. This is just some x and y value inside of the bounds from 0, 0 to the maximum, which is the width and height of our geometry, our quad here, right? And then what we do is we say, okay, that's where the pixel is, but that's a pixel on the real screen. The art is made up of pixels which are being enlarged, right? And so we might say that the pixels fill this space at a granularity that looks like this, right? We might go... right? So what we have is this white pixel point is finding out that it's inside of one of these large pixels, and in a first pass sense we could say that that's what tells it what color it is. But the issue is, what if the point we're picking happens to be near an edge, right? So if, I don't know what the granularity is here, but this doesn't quite look like it's near an edge. But I'll show you what the steps of the process look like from here. And you'll see how we can make an algorithm which, when it's in the center of the pixel, when it's well placed in the middle, we just get one solid color for this pixel. Or for this, this pixel gets a color solidly decided by one spot inside the original art. But pixels close to the edge will need some kind of blend, and the amount of blend they need is equal to, like, the amount of, a pixel right here on this edge, if it was right smack in the center, if the center of this pixel hit the edge between these two large megapixel like shapes, the two squares from the larger enlarged art, then it should be a 50-50 split. If it's 90% contained in this one and 10% contained in this one, then it should be an interpolation with a 0.9 weight here and a 0.1 weight here, right? That's the basic idea. It's a linear interpolation. Eventually, you're fully contained inside of one pixel. You get all of that pixel's color. But if you're halfway, you get 50-50, and the proportion of each pixel from the art that your physical pixel overlaps, that tells you how much of that color should be blended in. Now, and that works also when you're like here, you get a quarter from each, right? You can have a four-way blend. That's the bilinear sample. Now, the idea of all of this is that bilinear sampling is already built into texture sampling, right? This is always how you sample a texture anyway. The difference is just we want to kind of clamp, a fancy kind of clamping of the granularity of when that gets applied. So, first thing that's going to happen is that this, let's name this P. So this is a pixel center, to write it down, P equals the pixel center that we started with. And we're going to make a couple of changes to it. We're going to subtract the object center. And we're going to add in 0.5, 0.5. So if our just to translate what that means, our point P is not the center of a pixel. That's what OpenGL gives you. Our point P is the bottom right of a pixel, okay? If our object is on integer coordinates. But it isn't necessarily on integer coordinates. But the intuition you can have here is if we were to align our art to the pixel grid, then what's happening is at the pixel center, we're grabbing the bottom right of a pixel, okay? And another way to think about that that's useful is this is the maximal point on the pixel. Everything that, whatever that's important because which part, the hit test of that against the base art will tell us that we are either fully contained inside the point we hit, right? If this is the bottom right of a pixel that looks like this, then this pixel is either fully contained inside this blue thing or it's contained in some combination of these 4 points here, right? We know which 4 it is. If this was going to overlap here, it couldn't hit this pixel, it would have to hit this one. So we always know which ones we're looking at. We're looking at, in particular, we are interested in an interpolation, a bilinear interpolation at this point here, although we don't know the exact weights yet. We have to figure out how we're going to calculate that, but the idea is that, how's the right way to draw this? Rounds down to a Q right there, right? So Q equals, well, let's not put it that way. Let's say the first thing we're going to do, we're going to do this in 2 steps. The first thing we're going to do is we're going to shift from the coordinate space of pixels to the coordinate space of the source art. So instead of screen pixels, it's the art pixels. And so in that space, we'll name this point Q. So P and Q are the same point in 2 different spaces. They don't have the same values, right? Q is just P divided by the scale factors. Although that's a little bit confusing. So how do I want to write this? We'll write 1 over scale. We'll pretend like scale is a scalar, and we'll multiply that by P, right? Now this gets more complex. We can actually just do this as a Hadamard with 2 independent scales if we wanted. So like, here, let me just show you what I mean. X and Y don't have to have the same scale. They work perfectly fine independent from each other. So say we had scale X and scale Y going on different parts of the circle there, and then this would be and 110, 110. We'll decrease the size of the scaling a little bit. Let's have the thing stop wiggling, and let's have these go fast. And maybe I made the size of the scaling a little too small. Show us. Right? So X and Y can scale separately if we want to. But for now, I'm going to pretend like we're just going to use a single fixed scalar, because the math difference is really just you replace scalar multiplications with Hadamard multiplications when the time comes, and then you're good to go. Now, the next thing we're going to do is we're going to look at Q, like I was saying, rounded down to this point. So this is the floor of Q, right? And then another thing we want to look at is from the perspective of just this box. If we imagine that this is 0, 0, if that is 0, 0, then we can ask how big is Q from this perspective, right? So that would be Q minus the floor of Q, or the fractional part of Q, right? This is the fractional part of Q. And what we want to do is, so that is going to be in the range of 0, 0 to 1, 1, right? This is it's a two-dimensional vector with with a unit square range. And what we do is we ask, okay, this is how far over and how far down you have to go from the top of the large pixel. So this gives us a coordinate for the large pixel. When we do the subtract, or when we take the fraction, what we are getting is how far into the pixel we are. And then if what we do is we multiply that by the scale factor again, what we'll get is how many real-world physical pixels we've moved to the right and down from here. So we can call this something like delta equals the fractional part. Why don't we actually give all these things names that I skipped? Let's back this up. Let's back this up and name the intermediates. So we'll call Q is Q. Q naught will be the rounded version that is representing the origin of the large pixel from the source art, where this is the point on the screen where this large pixel gets placed, and that's going to be called Q naught, the origin of this pixel. Now, what we want is to calculate delta. Delta is the size of this vector here in pixels which is the fractional part of Q times the scale factor. The fractional part of Q could be 0.5, but if we are drawing this as a 10 by 10, right, if this megapixel here, if this large source art pixel covers 10 screen pixels, then the fact that we're halfway through means we've covered 5 pixels already, right? So the fractional part of Q times the scale gives us the delta, the size of that piece there. Now what we want to do is we want to clamp that, right? So like I said, that could be as large as the scale factor, right? Because fractional Q could be very, very close to 1. So this could be very, very close to the scale, or it could be very, very close to 0. What we're going to then do is clamp the top so that this delta cannot be larger than 1, 1. So we clamp top on delta 1, right? So now this went from being something that ranges from 0, 0 to scale to something that ranges from 0, 0 to 1, 1. Now why is that helpful? Because the only time, we actually want anything other than just this pixel, right? If this is a 10 by 10 and this is 0.5 and this is 0.3, then we're at now 5 and 3 pixels into the large one. These should be irrelevant. We want a solid color from one spot, which means we want to sample right from the center, right? So basically, if this is if I were to, let me pick another color here. I'm going to just draw over all of this. And you can imagine that there's a space in here. If the bottom right of our actual screen pixel is somewhere inside of, let's say, this range. Whoops, that's the wrong color. If it is somewhere inside of this range, we'll call that the range of interpolation or something, right? That's the section where if the bottom right of the pixel is inside that box, then we need to interpolate it bilinearly with these guys, some amount. But if we're anywhere inside of this range, here, in this range, everything should just sample from this one spot. So this white pixel here is ultimately going to want to map to a texel coordinate. A texel coordinate is a coordinate inside the texture itself, right? Not a coordinate in the screen space, but somewhere invisibly there, off of the screen, but in memory there's a texture, and texels are coordinates into that texture. The texel coordinate, which samples this big pixel from the texture, is the very center of it. So all of the things shaded here are aiming for right here as their sampling point. Everything in this range here is going to aim for, so these all map to there, and so on and so on. But there's a box that looks like this that represents all the ways you could bilinearly interpolate these 4 points. So any point you pick inside this box blends when you're picking your texel, right? When you go to pick your texel, anywhere that you place the coordinate in this box blends these 4 points. And what we're trying to do is we're trying to map this corner to this corner. This corner. Wait, sorry, that's not quite right. Right. No, that's true. Okay, so this is going to go here because that's the very corner of it. If the bottom right of our pixel is right here, right? Remember, P and Q are the bottom right of the pixel, not the center of it. So if it were right here, it would round down to this, but it would actually be a pixel totally contained inside of this box, which you would accomplish by sending this all the way to this corner, right? This would sample from that spot. If you were to get a point like right here, you would want that to map to somewhere over here. Does this make sense? Like each of these corners is going to have to map like this, I'm pretty sure. Because, if this is the bottom right of a pixel, well, that pixel goes right here, and that pixel then is fully contained in this box, so it should actually be sampling over here. But if you move in just a little bit here, right, a spot like this should map to a spot like this. So we're taking everything in this box and blowing it up to this space, and everything else that's in that original pixel, because remember our input space is the blue box here. Everything else that is shaded should go here. So this is the clamping, right? This is all stuff bigger than this. So like, I guess I said everything in here should go to here, but like a point right here should actually go clamp to here. And I guess that would put it, let's see, it'd be like right here, right? Because it rounds down to this, but it's still only halfway between these two. So this section is partially interpolated, and this section is partially interpolated. Whatever, you get it. The space is a little hard to draw, but like this whole section here all is clamping to this. This section is clamping to this bottom edge. This section is clamping to this right edge. And everything inside this little box is mapping to this whole big box. And that way, what's supposed to happen, again, remember, is all of these which are fully contained inside this pixel will map to grabbing exactly just this value. But anywhere where we need bilinear interpolation because the bottom of our pixel is partially in this, or the bottom of our pixels is always here, but if our whole pixel is partially overlapping, then we need the right amount of bilinear interpolation for that spot. And the way to get the right amount of bilinear interpolation through the texture sampler is to then map it to a texel, which is this box here, right? And each of those spots represents some amount of blending that we need. So that's the way it works. But you'll notice this entire description, right, just to complete the idea here, the final anti-aliased version of Q is you take that Q naught, the base point, you add in the clamped delta. So the clamped delta is somewhere inside this box. All of these points clamp down to this corner, all of these points clamp to this edge, all of these points clamp to this edge. But they are in the space that is scaled up. So if this is 0, 0, right, that's where we started. We're now adding in an amount where we are in this box here. We take these points, clamp them down, and also no, yeah, that's right. So we're in this box here. How does that part go? No, it's not quite true to say that it's clamped to that box. Really what's happening is points inside this pixel are first being scaled up so that they are... So Q plus delta would be a point in this texel. No. I'm getting a little bit confused here. What is happening? Q naught is here. Delta is how many pixels? Okay, so the confusing thing is delta is not in the same space as you think. Delta itself is actually scaled back up, so it's a difference between two things measured in the space of pixels. And that's what this is too, except that it's clamped, so that if you had something as large as right. Okay, right. So what's happening at this point is we are basically grabbing a point somewhere in this box, right? This box here. This is Q0. It's where we start, and we're adding in a unit. We're adding in a point from the unit square 0, 0 to 1, 1. So it's somewhere in here now, with all the points in the shaded space mapping to either this edge, or just this point, depending on which shaded space they're in. And all the points in this box are now being blown up and scattered across this box, right? Like this. But then the final step is, once you've got a point in that box, you subtract to get a texel coordinate. So you go minus 0.5, 0.5. So this is not about pixel centers, this is about texel centers. This takes us from the bottom right coordinate of whatever, like this would give us the bottom right corner here when what we wanted was exactly this point. So we subtracted 0.5. It would give us this top left corner when what we would actually want is the exact center of this pixel. And if the bottom of my pixel is right here, this is the bottom right of my pixel, then I have a pixel that looks about like this. And so it makes sense that the center of this, right, should map to the point that straddles these lines, so it'll equally sample all 4 points. Right. So that takes that gives us our cue for sampling that's been put through an anti-aliasing mapping. And then you just get, color equals sample from the texture at that point, right? There's the whole story. Now, this all works, but you'll notice this doesn't take into account there's no rotation or skewing or flipping possible here. This figures out what's happening by assuming that the texture and the quad are simple axis aligned bounding boxes that map to each other on through the same alignment, So the question is, how to generalize the formulae I guess we're not doing handwriting today. This is just a fun day. Like I said, this is not as much of a serious part of the project as other things. So if I'm just having fun anyways, then I'm not going to torture myself with handwriting practice. Ugh. Okay. So let's see if we can figure out how we generalize it. So I want the inputs to be an object center, or the top left or whatever. This is the point which corresponds to the top left of the texture. I want an X. This will be called the let's call this the X axis, and I want a Y axis, and I also want a texture and texture dimensions. Now, what'll happen these are my inputs. Yeah, BYP, Object Origin's a much better name. Good thinking. Okay. And then that's going to have some of the following things happen. We are going to, very easily, we can build the quad. The pair of triangles is just going to be a matter of mapping -1 and 1 to a new range instead of through rect. But some other questions are going to come up, and I think the best way to answer them will be to look at it through the code. What is Q now? Right? Q used to just be P and then divided by the scale, but there is no such thing as divided by the scale anymore. The scale, not only are they separate, but they're to do that, the inverse from P, going from P to Q is essentially like an inversion operation, right? P is in the space of real pixels, and Q is in the space of the large texels of our source art. The mapping from P to Q is the inverse of the mapping from Q to P, and the mapping from Q to P is what we call the scale factor, right? 0, 0 on the source art maps to everything from 0, 0 up to 9, 9. There's 1, 1 starts at the position 10, 10, right? The texel 1, 1 starts at the pixel 10, 10. There's a times 10 scale factor when that's the scale factor. And so dividing by the scale factor is inverting that. This is the inversion, or to put another way, a mapping from the space of P to the space of Q, or from the space of pixels to the space of texels. So this defines a mapping from object origin x-axis and y-axis. These form a mapping from the texel space to the pixel space by P equals object origin plus a matrix which is made up of an x-axis and a y-axis multiplied by q. Right? So this is actually a 2 by 2 vector, since x-axis and y-axis are each vectors of size 2. So these are the column orientation of the x-axis vector and y-axis vector form this 2 by 2 matrix. So the inverse is a mapping from pixel space to texel space which is just going to be q equals x-axis, y-axis. That needs to be inverted and multiplied by p minus the object origin. So that's a new way to get q. Instead of dividing by the scale factor, we are taking p. We already knew. So before we were baking this into the idea of subtract of p. Here we're kind of saying actually this maybe belonged down here. Let me put in some notes after the fact. Cool. So there's the calculation of q. Now q is going to be easily turned into q naught that way, but what is this? What is times scale? Well, again, the idea here is this part is the same, so the fraction of q is the same. It's the, after we mapped p to q, q is just in this space of texels, and then we get q naught, and we're interested in basically q minus q naught. That's all that the fraction of q means, is q minus q naught, right? Now this time scale then looks like placing this delta, this q minus q naught, back into the space of P, right? So this would be a mapping from texel coordinates to pixel coordinates, but without object origin, I think, being part of it. And let me think about what that means. That means, yeah, it's like if I have this pixel coordinate here, then I map to some amount of q. Oh, this isn't quite right. So let me just replace this with a matrix we'll call M. And this is also replaced with M. The problem with these is this is not actually a mapping. This is not actually a mapping from what I was giving wasn't a mapping from a pixel coordinate to, or from a texel coordinate to a pixel. It was from a UV space. So I was looking at it like from 0 to 1 and from 0 to 1. But in order to do the clamping correctly, I actually need to put it in texel space. The difference is in UV space, the top left, the origin point is 0, 0, and the bottom right of the coordinate is 1, 1, and everything that you can sample is somewhere in that range from 0 to 1. But when you want to think of each texel as discrete, and you want to index them as integers, sort of, or you want to sample them by their center points, for instance, and do this like box-based clamping logic, you then need to actually multiply it by the width and height of the texture. So instead of going from 0, 0 to 1, 1, you go from 0, 0 to texture with texture height. And I skipped that part before, but we can set it up so that M will equal textdim dot x 0, 0 textdim dot y times x-axis y-axis. Right, so now if I give you a texel, no, this isn't it either. Nice try, getting closer. If I give you a texel, first thing you'll do will be the unscale the texel, and then you'll put it through x-axis, y-axis. Okay, so if I had a UV coordinate, this would be correct, but I don't. That's why I need text dim 1 over textdim dot x 0, 0, 1 over textdim dot y. So there's our formula for M, the matrix. We'll need to calculate it and invert it to run the inverse. So this is the part that looks like 1 divided by scale. This part then moves us into pixel space, and then, oh wait, no, this is supposed to be, Right. Scale is funny. Scale is not just the width and height of the output rectangle, but it's also divided by. So scale is sort of like 1 over scale is like having the times the UV times the textile space divided by this is times textile space divided by uh, pixel space, and this one here is times pixel space divided by textile space. And so those are getting replaced by these linear maps. Instead of times and divide by scale, like a scale factor, it's times a matrix and times its inverse. So m takes us from m plus this object origin takes us from a textile coordinate to a pixel coordinate, and the inverse of m with this formula takes us from a pixel coordinate to a textile coordinate. Okay. And they basically look like this is x-axis, y-axis. This is the part that's times pixel space, and this is divided by textile space. Right? Okay. Okay. So you'll calculate this the same. You'll calculate this the same. Except that when you say we calculate this the same, we mean we are going to do the fractional part of q is a vector, and we'll multiply it by m on this side. And then we'll not add in the object origin. We're only interested in, right, because you could think of this as applying the mapping to both q and q naught, and then when you subtract them, the object origins will cancel out. And then what happens here is q naught plus that's fine, minus, I don't know if, okay, so I don't know about the pixel center part or the final subtract, but I'm going to need to take a quick break. Let's see here. I'll be back in 5 minutes or so to pick this up. Ugh, I don't really feel like doing it with 4-coder today. Let's do it a different way. BYP, I don't think that I need um, to worry about them being orthogonal, right? So it's true, x-axis and y-axis might not be orthogonal. The angle here might be 60 degrees. I just need these to be linearly independent, though. That way it's invertible, right? Orthogonality is not a requirement of invertibility. They just need to be linearly independent, right? I can't submit two, if I have two things, if x-axis and y-axis are collinear, then it essentially means there's nothing to render, because it all collapses down to an infinitesimal line segment. But if it's linearly independent at all, then it'll create a trapezoid, and each point in that trapezoid will map uniquely to the texture. Right. Okay, but am I gonna inner product? I'm not sure if I follow the significance. Like that's a fine. Like that's an abstract concept I get, but I don't see the mapping to anything that I've gonna have to do here. To get the UV weights in the object space. All right. Yeah, I might end up running into needing to understand what you're talking about. We'll see. This is new territory for me that I'm breaking into, and if I can't figure it all out, if I charge ahead and I run into a wall, I'll be happy to have the hint that I need to rethink the inner product here. Yeah, the last thing I have to think about is this and this. I think everything else makes sense, to, at least from where I'm standing. The one thing I'm stumped by is the way this worked before. I would get a P, I'd get a pixel center, make a P, which was look at the bottom right of the pixel before mapping it into texel space. Which made sense because it of how it related to I mean, the simplest guess would be that this is the same. I'm gonna just walk through a couple examples and see if it still looks the same, which would mean this and this still do the same thing. So we start with the bottom right corner of a pixel. And these form a geometry shape like this. It's about here, right? Triangulated right here. So there's the geometry it pops out. Now we get a point P, which is a pixel center. I don't think I want to just assume that I modify that this still makes sense now that I'm looking at it. It seems like that would be strange. I get a pixel center like this. The alternative, if I were to transfer the P, the 0.5, the thing which is concerning is these feel like they make sense only because we knew the axis and y-axis looked like this, right? But what happens when this isn't the case that confuses me? I think the case that most bothers my intuition is if I were to do something like put down an origin here, set up an x-axis here, so the top of the shape would go here, the y-axis here, and then something like right here, here, forms the trapezoid. So then a pixel point here might look like this. Right? And so we get, when we look at it from the point of view of textile coordinates, we see this, but what we initially have is actually just this thing still, right? This is our pixel center. And now if I add 0.5, it's like I'm moving towards the origin instead of away from it. That's what makes me feel uncomfortable, like this doesn't make sense anymore. But then again, when I try to think of how would I fix this thing which confuses me, I don't know what you mean by those coordinates need to be mapped. I know a basis. The pixel center here is in the screen space, and the 0.5 are. There's only two spaces here. This is in the pixel space. And it seems like the only way I would generalize it is I would just apply the mapping afterwards. I mean, it's confusing because, say this is my pixel center, then the pixel around it might look like this. And so the bottom right of the pixel is this point here. Now, before, what this did, what the effect this had, was it had the effect of moving me away from the origin, always. But now it moves me towards the origin. And that's the part, like, it feels to me like there's an assumption about why this works that is being violated that I don't know. Right? Like, the way I understood it, the point, the reason to do this was so that when we, you know, if I took a pixel center, if this was P and I took this pixel center instead of P, or to put it another way, if I got a pixel center right here, right in between all these things, then it would look like an integer. But how do I want to say this? It would look like an integer in the space of it once it was converted to Q, right? It would obviously have a 0.5 and a 0.5 in P. But then if you didn't shift it first to get a bottom right, and you just took a pixel center, and then you put it into Q, into the space of the texel, you'd get these integer coordinates here. And you'd have to know that that means you are dead center between them. And the box would become this part here. Right? You'd want to map everything in this box to everything in this box. And clamp on all these sides. Okay, this gives me an idea of an experiment. I think I could do this without having to touch the bottom right of the box. So this was just inspired off of how it was in the shader toy example the D7 Samurai has that I learned it from in the first place, but I think there might be another way to do it. So instead of offsetting here, we'll just take the pixel center, and then let's see, I'm gonna expand things out even more. Q naught is gonna be the floor of Q, like I have here. Okay, so the first issue here is now I can't use fraction, so I'm gonna have to do delta equals Q minus Q naught, and then delta C is gonna be clamp delta between negative 0.5 and 0.5. I don't know if it'll let me use clamp on a vector like that, but hopefully. So that'll clamp us, instead of to the unit from 0 to 1, it'll be the unit from negative 5 to negative 0.5 to positive 0.5. And this here needs to be times the scale. So this replaces this. This replaces this. And this gets removed. And the reason that gets removed is we used to be moving pixel bottom rights of pixels around. And so when we took Q0, which was in the texel space, and added this in, wait, hold on, let me think. Q0 is the integer coordinate. I think this works. Q0 is the integer coordinate for the spot we want to sample, like for the texel that our pixel center is in, right? If this comes out as 0, so Q and Q0 are the same exact thing, then this will come out as 0, and this will come out as 0, and we'll end up sampling all four equally, right? We'll have an integer. If this turns out to be big, and we multiply it up, and then we clamp and find out that it's bigger than 0.5 and it's going to stay at 0.5, then this becomes 0.5, 0.5, and we grab all from the bottom right. If it's way off into the left, we'll up into the left, because they're both less than negative 0.5, then this will subtract that 0.5. Right. This seems like the right thing to do, right? I think this does it. I don't know. That looks kind of... It's a little hard to tell with the stretching, though. Stretching is not the one I've been comparing against this whole time. Let's back off to simple scaling and wiggling. Make sure everything looks good that way. No, something's wrong now. Okay. So here's the new idea. The old idea was P equals this minus or plus 0.5. This is a clamp from 0 to 1. And then we subtract that 0.5 at the end. Okay, that's doing the right thing again. So I want to change from this to this. I don't know if you can see the difference. It's a little bit subtle, but it's pretty clear to me that I get the like distortion and shimmering effect around the edges of all the pixels. So what's different besides this? Well, let's take like minor mutations of this. So here's the one that works. But here's the one we're gonna work on. So I wanna say if I were to just shift this up to here and this to this, it should all be the same. You can't tell the difference? That's too bad. Thought video compression might get in the way. Okay, so that's working. We can keep on moving that minus 0.5 up the stack here. So when that goes in there, it's going to get a divided by scale. But I can't, okay, so this is where it matters. It matters because of the floor. I can't just bake it into Q without affecting when the rounding down happens. Okay, okay. So the point of this is to help with the rounding. This part works. So I can take a pixel center, and it is in fact going to map to that integer coordinate there. The issue is that this point here, if this is my pixel center, I need it to round to this when I find Q naught. So it's no longer about floor, because floor made sense when we were looking at points inside this range. Points inside this range all mapped to this. Now what's weird is it's more like points inside this range, right? What would make most sense is if it was points inside this range. How could it be that way? I mean, that's just round to nearest, right? Is there a round? Like not floor or ceiling, but nearest? GLSL. Round to nearest. So if I do round, the difference is to make round into a floor, what you do is you say minus 0.5 first, right? Okay, I'm a little lost. Let me redo this again with the working one. So the changes that I want to make are, first of all, I want to say instead of subtracting here, let's promote this up to here, and let's clamp this range. That should work. And I think it does. Next, instead of floor, I should round and use a minus 0.5. That should be the same thing. Now when I move this into here, it gets a divide by scale. And then I want to move it again to here to think of it as coming with that Q. That Q this is weird because this and this don't agree. And why is that? I would expect them to agree. Because, like, if I move this up to here, then I need to add this and counterset that to make that the same. Then, of course, this folds away. And then that cancels with that. But now this is Q minus 0.5 plus 0.5 over scale. That's like, I mean, that's real strange. That's 0.5 times 1 over scale minus 1. I mean, what is that, right? Maybe that's that. But this just ends up being hiding the same little quirk here. And it feels like it should be wrong now. Okay, okay. I'm lost again. Try again. Somewhere in there's got to be a way to understand this. So I get a pixel center somewhere in this box. This box is, let's see, 0, 1, 2.5, 2.5 to 3.5, 3.5 in texel space. If it's times 10, then it's 25 to 35, right? So 25.5, 25.6, 25.7, 25.8, 25.9. 30.5. So an X of 30.5, a Y of 25.5. And what we want to do is clamp it all the way to here. Basically, if your pixel center is here, 25.5, we divide by 10, we get 2.55, which should round to the integer 3. 3. Then the difference is this minus q naught is 0.45 times 10, that's 4.5, clamped to negative 0.5. So it's negative 0.45 times 10 is negative 4.5, clamped to negative 0.5. So you end up right getting 3 minus 0.5. That seems like it should just work. Let me just do this from scratch instead of trying to make it line up. So pixel center minus the origin. Q translates the pixel center into, this is Q equals map P to Q. Round Q to the nearest integers. Take the difference of Q times scale and then clamp it to the half unitable box like this. Q naught plus delta C sample. That should do it, I think. Okay, I think maybe that is working. Compare that to the goal real quick and see, was I crazy for thinking it wasn't working before, or did I miss something? No, that's definitely busted. Big time. What was different was was that I was just flooring. Okay. Yeah, that's the only problem. Okay. So there it is. Now I'm curious why I couldn't transform. Here's the working version. We're done. But I'd like to see, just one more time going through the math, why couldn't I transform these by manipulating them one step at a time? So delta C minus 0.5, you go there. If I push it in like this. I subtract that much from each one. This simplifies to this. This simplifies to this. And this becomes delta minus 0.5. If I bring it up another level, I get this. Now, I'm gonna put this in here. I can push the 0.5 down through the system. So there's a 0.5 there. That becomes plus 0.5 times divided by scale. This becomes floor of that. That. This pops out of the multiply and loses that, and these cancel. But how does this become rounding? Right, this doesn't make sense to me. This part here is odd. Because it didn't cancel out right. This should have become round Q, and then it would all match. But that would have to be this. Real odd to me. I'm missing something about how these relate to each other. I just want to spot it. Delta C absorbs this. Delta absorbs this, and these each absorb this. This becomes a part of the mapping. So what's happening? What's happening? What's happening? What's happening? Well, honestly, I'm not sure. I just don't get it. But it feels like this might be where the assumption that was confusing me before might be linking right here. It might be lurking right here by somehow. My logic is I've got P, which is the center of a pixel. Oh, I want to just do that. I get the nearest integer. I get the difference. And multiply by the scale. Now that's a vector from there to there. I'm prone to thinking there's something wrong with the original logic here, because it seems so straightforward this way. Q equals pixel center minus the origin mapped to and then scaled into the texel space, round to the nearest texel integer coordinate. Take the difference from the point we hit and the integer lattice point we hit and scale that back into the pixel space to ask how many pixels away from the from the lattice point are we, right? How many pixels away are we? Clamp that so that if we're more than half a pixel away, we know that we're entirely inside that one texel. Does that make sense? There's a little bit of an assumption here about something. Let me think. So this then gives me this thing here, this delta. Is the difference between 2 points in texel space, and that difference is then mapped back to pixel space. Let me think. What's weird about that? If you were multiplying by a matrix that moves that to like it's still not going to be bigger than the range of that is still going to be up to half a pixel left or right or up or down. I think my problem is that the clamp is happening in pixel space, which doesn't quite make sense. I think you can get away with clamping in pixel space, but you're actually trying to clamp in texel space, I think, right? You have this confusing thing where delta kind of moves through both. Delta, I'm saying that it's in pixel space because I'm applying the mapping back into pixel space. But the clamping here is set up so that I can make it additive to something in texel space. So it's kind of a trick where it's in both. And I want to wrap my head around why that is and what it really means. What I think is happening is that Q, wherever it is, here it's right here. I probably need a new picture, but Q is somewhere. Hanging out. Here's Q, whatever. And we are trying to make a mapping so that if the texel coordinate Q is near Q0, and right, so what we would need to know is what's the shape of this clamping box here that needs to map out to those. Right. I think the assumption that that the 0.5 is using, is also a part of the assumption the floor is using, which is that a simple unit box is the correct way to clamp. Okay. So I need to draw again. But this time, I don't think this is the right starting point. This is trying to think about how rotation is confusing me. I think what I need to do is not worry about shifting from the pixel center and instead worry about understanding what really needs to happen with that clamp. So I want just a slightly sheer trapezoid coordinate space here. Like, here's X, here's Y. If that's our object, then our textile space is like this. Here's the boundaries of the texture in pixel space, and then subdivide it. All right, so here's a 8x8 texture mapped onto this trapezoid here with large trapezoidal interior, like the pixels of the art are becoming trapezoids on the screen with comparable size to the, or comparable with a, symmetric shape to the whole. And the question that we are trying to answer is, what do we do with a pixel whose center is right here that forms a box on the screen like this? That's not a very good pixel center. Let me draw the pixel first and then the pixel center. Here's the pixel. Here's the pixel center. So I think the way I want to think about it, oops, what did I just undo? We'll undo it. Okay, yeah, undo that. Okay. Give me this. I just want to figure out, right, if I end up finding this point, for instance, then that means I'm in a box about this shape, or a trapezoid. I have a pixel center somewhere inside of here. Right? Any pixel center in here should use this integer, which is 3, 3, this integer coordinate, because it's definitely a bilinear sample from these guys. And then the trick is we don't want linear filtering anywhere except inside of a small range close to the center here. Right, like if we zoom in, there's a smaller range, the same basic shape. Around that intersection point. And what we want is everyone in these spaces outside I see how I can do this better. Back it up, back it up, back it up, back it up. Okay, vertical line, vertical line, diagonal, diagonal. Okay, everyone in this space here maps to this point. Everyone in this space here maps to this point. Everyone in this space here maps to this point. Everyone in this space here maps to this point. Everyone in this space here maps to this point. Everyone in this space, or to this edge. Here. I feel like this picture isn't quite going to work. Let's do green for these guys. So if you're here, you map to this point here. Similarly for each one of these corner boxes. Then, yeah, if you're in any of these subzones here, where you're not inside the interior box, then you're going to map to, like this one here, maps to this entire edge here, right? It expands out with this side here mapping. Here, actually, let me back it up again. I'm going to do this part this a different way. So we have this outside edge here is red. And things here map to there. 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 Things here map to there, right? Hopefully that makes sense. So it's expanding out. And similarly with all of these, they go out to these spots on the edge. And then this box here stretches out and spans the whole thing. So points here go here, points here go here, points here go here. You see what I'm saying? So like it's just kind of a, this gets blown up, and then the clamp is to prevent us from going outside those edges. So like a point right here maps to a point right here. A point right here maps to itself, and so on and so on. Bretolette, to show you what I'm working on, so you understand why I'm looking at giant pixels and then small pixels, is we got we got this little like pixel art thing going on. So we're doing pixel art, small, it's getting blown up, and then I'm trying to get a good formula for anti-aliasing so that you don't get like, flickering artifacts when things stretch and slide around. But now that I've got it working this way, I'm trying to get it working so that I can set arbitrary trapezoids like x-axis and y-axis so it can rotate and shear and stuff like that too. Okay, so we'll get Q easily. We'll get Q naught easily. The final thing we want is to get Q naught plus some kind of scaled and stretched. Okay, so delta isn't really in pixel space. I think once we look at this, we'll just see a square every time, right? This is a trapezoid in pixel space, but in texel space, we've already got a square and a square. The only issue is going to be figuring out what scale means at this point, I think. I think scale is just the length of the x-axis divided by the size of the quad. Like if this is an 8-pixel texture, right? If the pixel art has 8 pixels wide, and this diagonal has a absolute value length, a Euclidean length of 80, then each of these is like 10, 10, 10, and so this is like a 10, and you should be looking for pixel centers within 1/10 of this to get the right result, I think. So maybe this isn't actually about inverting, this isn't a mapping from this would be negative 0.5, negative 0.5. And if the difference in the resolutions is 10, that'll get multiplied to 5 and clamped back down to 0.5. This would be negative 0.05 away from this. When we multiply it by 10, it also becomes negative 0.5. Yeah, I think that's just it. So let's take the next step. I think I'm ready. So the rectangle gets replaced by an origin, an x-axis, and a y-axis. We come with a built-in assumption here that x-axis and y-axis are going to be linearly independent from each other if we submit them to the shader. Name that one to textdim now. And let's see here. We're going to extrapolate the pattern. We can no longer do it this way. P is now going to be calculated as V origin plus V x-axis times L dot x plus V y-axis times L dot y. And then we'll take that and map it to normal coordinates. Can't submit that, but we can pass on the origin, x-axis, and y-axis. These become ins over here. Now this isn't quite the same anymore. This is more like okay, I did a little bit of prepping over here too. We're going to want this matrix M. I've never actually, it's been a long time since I've touched matrices in GLSL. GLSL matrix, how does that work? Mat 3, is it 3 by 3? Nothing about constructing matrices from vectors, though. Here it is, mat, column, column, column. Okay, so I want x-axis, y-axis packed into a matrix and multiplied by this is text dimension now. Texture dimension f textdim dot x. This is whoops. Zero, 0, 1 over f textdim dot y. Textdim pixel center minus our origin. So here we go. Q equals the inverse of M times pixel center minus origin. Where do I get my inverse from? GLSL, do you have anything about inverse? GLSL invert 2 by 2. Okay, so I have to update what I'm submitting now. This is no longer going to work like this. It's now a size of v2 f32 times 4 kind of situation with quad going here, and quad putter covers 3 of these. Quad putter 0, 1, and 2 need to get filled with the origin and x-axis and y-axis. X-axis is v2 f32 rect dot x1 minus rect dot x0 0, and this one is the same thing with y's and the y coordinates. Okay. Now this is now called number 4 instead of number 1 in the vertex shader. Text dim. This is quad putter. This is quad putter +1. Oh, this takes a 2 and a V2F32 now. This takes a V2F32 and a 2. And this also works on number 3. There we go. FUV dim, VUV dim, try text dim. What do we got here? Line 16, huh? I think that's got to be the fragment shader. Okay. Rebuild. Check. FUV dim. Text dim. Last time. Okay, that looks like it's working, but I haven't actually tried to rotate or shear it, so if it was busted, how would I know? Now let's go and get this thing ready to upgrade. So instead of calculating rect, we're going to calculate origin x-axis, y-axis right here, with origin being V2F32 subtract center minus half dim x-axis equaling V2F32 half dim dot x times 2, 0. And the same thing again in the y coordinates. So now I don't have to specify a rect at all. I just specify those 3. And instead of deriving these from the rectangle, we pass them directly through. Nothing should be different yet. Cool. Okay. Set up a new animation parameter. I don't know. I think that's working. I think I wanted to see it more like this. Yeah. Cool. Okay. I don't have. I could test a Pokemon Sprite if I had one. But I grabbed this tile set, this Dungeon Crawl Stone Soup tile set, because it's on Open Game Art. So I could drop just about anything into the folder and give it a shot. I think anything should work. But I'm gonna just keep testing with what I got. The rotation matrix is, if my x-axis, if I have the one, 0, I think it's this, if I remember correctly. I need to work it through. This would give me cos t negative sine t for the y. so that seems wrong. The x component there, as I rotate it by t, the x value of it becomes cosine x. The y value of it becomes sine of x t, right? That's definitely right. Now if I put in 0, 1, and I rotate it by some amount, the x value of that is initially supposed to be sine of t, which is what I get. Oh wait, no. The x value is 0 at first, but then it goes negative. It's negative sine t on this side. And then the y value starting at 1 drops off. Yeah, so that's cosine t. Right, okay, so there's our matrix. I think that's too much. That's why it's happening weird, because this already has scale in it, so it's squaring the scale. Yeah, that makes sense. Okay. And then 20% is probably not too much. Okay, rotate sine, rotate cosine. Then I have to do the new x-axis is rot cos times x-axis dot x plus minus rot sine x-axis dot y, rot sine x-axis dot x plus rot sine cosine y at x-axis dot y. And x-axis gets replaced with y-axis in the same formula. Okay. It's kind of funny because it's rotating around its top left origin. But the point is I can put it anywhere and scale it and shear it. If I turn the rotation down really slow, turn up the speed on the shearing a little bit. There we go. And I can turn up the shear amount too. Okay. There we go. And just to make it a little more fun here, okay. Nice. Nice. Okay. That's all super cool. And as a final point, because the whole point was here to have fun anyways, let's turn on the rolling select and take a look. Yeah, yeah. Cool. Okay, I think this is a good amount of progress from where I started. We got the anti-aliasing upgraded to work with arbitrary two-dimensional quads, or trapezoids at least. The next steps are going to involve dealing with the metadata. I want to be able to search through it. I want to be able to select one. I want to be able... Well, I could also try to track down that issue where there's some kind of artifact that leads to, like, little outlines that are totally not supposed to be there if everything's working correctly. It's definitely a bug or an artifact. But I have to find an example, and so it might be easier to do the metadata part first. I'm not sure. I can see it, like, there it was. But I don't know how I'm going to track down one of those. In order to do the metadata, I'm going to have to set up font rendering, and I'm going to have to probably start dealing with keyboard inputs and mouse inputs and stuff. So that might be more than what can be done in just a single day. But there was, again, I want to find like a few in a row that are showing the problem so I can really point it out. But I'll come back to later today to do... I'll come back later today to do the first steps of that. I don't think I'll expect to get a whole bunch of it done all at once or anything like that, but I expect we can make some reasonable progress on being able to turn this into a widget, or not a widget, a viewer that I can actually interact with and extract data from and stuff like that. I'm just watching intently for maybe an opportunity to point out the artifact before I sign off for lunch. Give me an example. Okay, well, I'm going to let it go and go get some lunch. I will be back later today to get started on some of that other stuff that I was just talking about, the metadata UI building part, all right? So see you before long.